I am Daniele Theseider Dupré, and I'm presenting our work on user action representation and automated reasoning for the forensic analysis of mobile devices, co-authored with Cosimo Anglano, Massimo Canonico, Laura Giordano, and Marco Guazzone. Our contribution is twofold. On the one hand, we proposed a way for structuring the representation of the actions that have been identified as action of interest for the forensic analysis of mobile devices. We propose that such actions should be described at different levels of abstraction. One is the level relevant for stakeholders such as lawyers, judges and prosecutors that are not experts in ICT. So for them, for example, it matters whether the suspect has sent a message to another person, but they're not necessarily interested in knowing which specific application has been used. While of course the application is relevant for analyzing the application itself and reproducing the actions on the device in order to analyze the traces that are left and that can provide evidence for them. Actually, however, the level suitable for associating such artifacts to the action may be different from the previous one. Because, for example, actions that are made in the same way in an application may leave different traces depending on the specific version of the application. Our second contribution is in providing a way for performing automated reasoning in computational logic, in particular in answer-set programming, for reasoning about actions, evidence for actions, inferring that action has been performed from the data on the device, and inferring them at the previously described different levels of abstraction. There are actually two types of analysis to be considered in our work. One is the a priori analysis, that is the one that is performed in order to identify which are the actions of interest for an application and relating such action types to artifacts that are left on the device. The results of such an analysis can be used in the analysis of a specific device in order to establish that an action has occurred based on the evidence. The a priori analysis is supported by previous work by my co-authors, Anglano, Canonico and Guazzone, on Amphora, that is the Android Forensics Automator. Such an analysis should first design some experiments to be performed on the device, installing the application, characterizing the footprint of the application, that is the directories on the file system of the device that are used by the application, and then performing the experiments in order to find out the traces that are left. Amphora supports this process with the gray boxes, that is, allows to install the application in a virtual version of the device, analyzes when the directories that are used, that are accessed when the application is run, and then allows to perform the experiments by performing the action in an emulated version of the device, and finding out the differences, the traces that are left on the devices, in particular analyzing the different differences before and after the actions, differences in the directory and in the contents of databases used by the application. For the action representation, we propose to organize for this way for the example of the action, the abstract action of sending a message. That is, person A sent a message to B at a given time, possibly with some text and attachment. Such an action can have several more specific actions, that is, sending a message from within an application, or, for example, sharing an image, that is, first selecting an image to share and then choosing the application. This can be further refined in, for example, sharing an image from the SD card or from internal memory. Sending a message from the application can be refined in sending a message from a specific application. And at some level in this hierarchy, we could be able to associate a sequence, or more generally a workflow of actions that allow to to perform the action on the device. We should associate such a description at the level such as all the subtree in the hierarchy. This description is suitable for all the subtree in the hierarchy. For example, this is a description of the action for sharing an image from the SD card, that is, first selecting the SD card, then choosing the image, then choosing the application. And in particular, if the application is Messenger, then at some point we have to tap the send button, and this is the action that actually leaves the traces. In particular, a file with the image is stored in a temporary directory, and some specific tuples are recorded in the SQLite database of the application in some specific tables. For automated reasoning, in principle, this should be formalized as abductive reasoning in a temporal setting. That is, knowledge is given in the form: if an action is performed, then some traces are left, and given some contents of the permanent memory of the device, we should hypothesize actions. That is, this is abductive reasoning. Hypothesize action in the past that explain current traces, that they imply the current traces. And this should, in general, include cases where there are some individual traces that can be generated by alternative action, so there would be need for discriminating between alternative explanations. For example, if we have action A that produces E1 and E2, action B that produces E1, and C that produces E2, if we have effects, if we observe E1 and E2, then either A occurred or B and C, and perhaps this could be discriminated by taking into account, with temporal reasoning, taking into account timestamps for E1 and E2. We should also, in general, consider the possibility that traces are cancelled. For example, temporary files could be cancelled, so that, for example, if again A produces E1 and E2, B produces E1, and C removes E2, then in order to explain E1, either A and then C have occurred, or just B. This would be the type of reasoning that should be done in principle. However, in practice, it turns out that there are artifacts that are specific to action types, because each application has its own database, and each action type leaves different traces. So this allows for providing rules of the form if traces, if there's a trace or a combination of traces, then an action has occurred. Or more precisely, we could limit to the permanent traces in the premise, because we don't want to model when we expect that some traces are cancelled. In the automated reasoning, we have to take into account the fact that a priori analysis could not be available for all possible versions of the application, in particular for the version that we are considering on the device under investigation. So we provide rules that conclude, for example, that we should use a priori analysis for a version of the application if this is an if the context we are considering is that version of the application and a priori analysis is available. Otherwise, if a priori analysis for the version under consideration is not available, we should use an available version that is closest in terms of version numbers to the one that is considered. In order to infer evidence for a specific action, we have rules like this. For example, there is evidence for an action of type sharing an image from the SD card with the specific application Facebook Messenger. If we use the a priori analysis for Facebook Messenger version 237 and some specific conditions that are specific to that version of the application hold on the contents of the SQLite database of the application. So these are conditions that retrieve that information from a representation of the contents of the database that is suitable for computational logic to be inspected in a computational logic tool. Back on the action representation, this allows us to infer that a specific action has occurred, and then that more abstract actions have occurred with rules like this. For example, there is evidence for an action sharing an image from the SD card if there is evidence that this has been done with a specific application, and then if this holds, there is evidence for the more abstract action of sharing an image, and then for the even more abstract version of action of sending a message. So a send message action can be inferred from a much more specific action. So to sum up, our contribution is in proposing a structured representation for the actions of interest in different levels of abstraction, and providing a way for inferring evidence for such actions using automated reasoning in computational logic. Thank you.